Okay, so today we are going to look at the reverse to expansions, which is factorization. I'm going to move at a fairly quick pace, guys, so do make sure you're focused. I'll let you know when you should write stuff down. And of course, when I say write stuff down, I mean in your exercise book and not, for example, on your desk. Okay, so before I have a look at success, before I look at the success criteria that are on the screen there, I just want to have a look at the summary of expansion techniques we've looked at, which is going to be really bad for the video recording because they're not going to see a thing. But anyway, the story so far, looking at the left-hand side of the board, is we have these expansion techniques. We have difference of two squares, dots, where A plus or minus B times A minus or plus B, operations changed order, is equal to A squared minus B squared. There's the dots. There's the difference of two squares. Okay, so if it's a plus to start with, it's a minus to end with. If it's a minus to start with, it's a plus to end with. And then the expansion is A squared minus B squared. So what we've done in an expansion is we have gone from a product of expressions to a series of the sum of terms, basically. There's no multiplication or division of the whole of the right-hand side. There's just bits and pieces that have been added and subtracted together. The second one, PS, doesn't stand for postscript. In this case, it stands for perfect square. A plus or minus B all squared is A squared plus or minus, so the sign carries through to the middle term, 2AB plus B squared. This is the year, guys. I feel it in my bones. This is the year that when you do your test for me, I'm not going to have anyone at any part of the test say that the expansion of this is A squared plus B squared. I just got this feeling about it. I'm excited because every year before then, I've had that people still going A squared plus B squared. There is a middle term. Remember, there is a middle term. The box method, where we've got two expressions or binomial expressions that have been multiplied together, we can use a box in order to multiply those things out, or the chicken beak method if you so wish. Okay, so that's the technique there that's written on the board. And then the last one I forgot, DL, is short for distributive law, not download or something else. A outside of B plus or minus C is equal to AB plus or minus AC. So we keep the sign through. But of course, if A were negative, then the signs would change in the middle. That's the distributive law. So they're the main expansion techniques covered so far. Please note that most of these things are scalable. So for example, I can go A plus B times C plus D times E plus F. You just need to use the box method a couple of times. Or I can make it A plus B times C plus D plus E. And for the distributive law, it could be A outside of B plus C minus D plus 4. So they're scalable like that. But that's the basic nature of the expansion techniques. This is your final chance to ask any questions about that before I move on to factorization. Because if there's any queries here at all and you don't ask them, then this next stage on factorization is just going to be a bit shaky. Okay. I hope you're not being too shy. So there are the success criteria there. I can factorize an expression by finding a common factor, factorize by seeing a pattern, factorize by grouping, and factorize by reverse box method or otherwise. Okay, so by the end of this lesson, I'd like you to be somewhat familiar with all of those techniques. Now, factorization, as I said, is the opposite of expansion. So I hope you would understand that factorization is like we're starting on the right-hand side, okay, with just a bunch of terms that have been added and subtracted together. But the result of factorization is that we have a product being things multiplied together, and the whole of that side multiplied together. I know that A squared is A multiplied by A, but then you've got minus B squared. So it's not the whole of the side multiplied together. Whereas on the left-hand side here, can you see it's something times something else? So that's in product form. So factorization turns an expression into a product of usually simpler expressions. Okay, so far? The second thing I wanted to say is that there is an order in that you should attempt to factorize an expression. Okay, and the order is actually the same order as the success criteria here. So this is where we're going to start doing a little bit of writing, and I'm going to give you just a couple of minutes to write them down. So basically, when I have an expression and I want to factorize it, first thing I'll do is I'll try and find a common factor. The second thing I'll do is I'll see if the expression fits a pattern. The third thing I'll do, actually I'll come back to that one, but kind of grouping if it's logical to do so. And then the last thing I will do is try and factorize by reverse box method. So really importantly, you often need to use more than one technique. So for example, you might find a common factor to start with, and then once you've found a common factor, you'll be left with this still big, long expression. And then you might say, oh, that expression is actually a perfect square. So you'll factorize it into a perfect square. I'm going to go through examples of each of these. You know, this is what success will look like by the end of this lesson, that you can identify them, and hopefully you've had enough practice that you can say, yep, I know how to do each of these. Okay, and if you don't, remember, if you say, well, I can find a common factor and I can factorize by reverse box method, but I'm pretty cruddy at finding the pattern, then that's your opportunity for growth, right? That's where you say, okay, that's what I need to practice. I don't need to practice factorization in general. I need to factorize this technique. That's good, isn't it? So make sure you look back at that success criteria and give yourself a rating towards the end of the lesson. I'm just going to zoom out now. So the success criteria will still be on the screen. So if you need to keep writing, but then you'll start seeing some of these examples. So what I'm going to do to keep it as fast as possible, I'm going to just go through an example of each one really quickly, not even give you an opportunity to really discuss it or work it out for yourself first, but I will take questions after each one. And if I can move through that really fast, then you'll get onto your practice and I can just help small groups out as necessary. So common factor. Finding a common factor is basically the opposite of the distributive law. So again, this is not that great for the video, but on the left-hand side of the board here, where I've got the distributive law written, you can basically see that on the right-hand side here, I have AB plus or minus AC. So if I work backwards, I can see that since A is a common factor of AB and AC, it can effectively be taken outside the brackets. And what's left over is the B plus or minus C inside the brackets. So I'm going to go through this with the example, but I just want to sort of give you a feel for it, for what we're doing here. So we're sort of doing reverse distributive law. So what we do, in practice, this is what we do. When we have a whole bunch of terms, the first thing we do is we have a look at the number part. So in this case, the big number, the coefficient, it's 3 and 9. Yes? We then ask ourselves, what's the biggest number that will go into 3 that will also go into 9? That's called the highest common factor. And the biggest number that will go into 3 and 9 is 3. And so we write 3 down, not necessarily in blue. So equals 3. And then for each variable in turn, we ask the same question. So in this case, I've got an x squared and an x. Now, x squared is just x times x. And so there is a common factor of x there and x there. So we write down x as well. I have no more variables to look at, and so 3x is the highest common factor of 3x squared plus 9x. What we do then is we open up the bracket and we work out what is left. And this is where you just need to use the distributive law to fill in the blanks. So it's a bit like this. 3x, maybe look at the board if you're busy writing stuff down just for this bit. 3x multiplied by what will give me this first term, 3x squared? The answer is just x. Okay, so 3x times x gives me 3x squared. The next thing is we look at the next sign along, so plus, and then we look at 9x and we say 3x times what will give me 9x? Well, looking at the numbers there, 3 times 3 is equal to 9, and x times 1 will give me x, so I don't need to add any extra x there. So it simply becomes 3x outside of x plus 3. Okay. Questions about common factors before I move on to the fitting a pattern? Okay, so 16 minus 9y squared. This is where things get a little bit hairy for you, all right? Because typically students will struggle to identify patterns initially. Now, you only have 2 patterns in grade 9 to worry about. Is it a difference of 2 squares or is it a perfect square? The answer might be neither, but let's just imagine there is. Well, in this case, there is, because it's under the heading fitting a pattern. So that's probably a pretty good giveaway that it does fit some sort of pattern. Then we see that we've got 2 terms there, 16, and we've got a minus, and then we've got 9y squared. So seeing that subtraction of 2 terms should immediately allow yourself to think, I wonder if this is a difference of 2 squares. And so the pattern would be, can this be written as a square, and can this be written as a square? Now, looking at the left-hand side of the board again, all I'm doing is I'm reversing this dots expansion. So I'm asking myself, do I have a squared minus b squared? Because if I do, I could write it as a plus b times a minus b. Now, in blue, I'm going to write out what that square is. You don't have to write this down when you're generally solving problems, but if it helps you, do it. So 16, for example, I can see is a square number. It's 4 squared. 9, I can see is a squared number. It's 3 squared. And y squared, I can see is a squared number because y squared is y squared. So we've got 3y squared. Am I making sense? So it's a squared minus b squared. Look what I'm circling, the whole of 3y. Okay, so all we're doing now, and again, look at the left-hand side of the board if it's a bit unclear to you. All we're doing is we're reversing that dots expansion. So we've got 4 squared minus 3y squared, and so that is equal to 4 plus 3y times 4 minus 3y. The 4 because we squared 4, and the 3y because 9y squared is 3y all squared. Any questions on that? So we're just reversing the dots expansion. Last chance before I move on. Coolio. Guess what the other pattern is? Perfect square. Okay, so but typically you don't know that off the top of your head, right? I mean, with practice you do. You go, oh yeah, that's perfect square, I can see that. But you don't have to know it. All you have to do is know you should look for it. Clearly, it is not a difference of 2 squares. Hot tip, when you got 3 terms, it's not a difference of 2 squares, right? Because it's 3 terms. So, and there's no minuses there either. That's the second hot tip. So I know it's not a difference of 2 squares, but is it a perfect square? Now again, looking at the left-hand side of the board, we can see that the expansion is some sort of number squared or term squared, some other kind of term squared, and then it's twice those terms in the middle. We need to ask ourselves, do we have that? So again, I'll draw it in blue, and you don't have to do this, but if it's helpful to you, please do it while you're doing your own solutions. It looks good. It doesn't necessarily mean it's definitely going to work out, but already I can see that 4 is a square number and 9 is a square number. Can you see how hard this would be if you didn't know your square numbers, by the way? I should be able to put plus 169 and you should be okay with that. So you should be able to identify everything up to 13 squared, all right? If you don't, get a list of them, practice them, do flashcards, whatever you can, so that when you see 25, you can go, yeah, that's 5 squared. When you see 49, 7 squared, etc. Okay, if you're not fluent with it yet, then you can fix that if you want to. So be fluent with everything up to 169, 13 squared. Okay, but anyway, I've kept them small. So if I have a look at the first term here, I'll see that 4 is 2 squared and x squared is x squared, and so I have 2x squared. So that's what you can do in your head, or you can just write it down literally. 9 I know is 3 squared, so that's all good. So I have a square at the start and a square at the end, and I have something in the middle. And what I want to do is I want to check, is 12x twice a, 2x, times b, 2 times 2 is 4, 4 times 3 is 12. So yeah, I have 12x in the middle. Does that kind of make sense what I did then? So I checked first, I had 2 squares in my expression. I do. The first and the last term is something squared. And then when I know what I'm squaring, I worked out, do I have twice that in the middle? Yeah, I do. So as soon as it fits that pattern, I can go straight to saying, okay, that's 2x, that's the first square. Now I check the middle, by the way, and I can see that I'm adding the middle term. And so that becomes 2x plus, and then the second one is 3 because it's 3 squared. So it becomes 2x plus 3 all squared. Just looking at the left-hand side of the board, again, remember that the middle term always keeps the same sign as the original expansion, if you like. So if that was 4x squared minus 12x plus 9, then the answer would be 2x minus 3 all squared. But because the middle term is plus, then it means that the factorized 2x plus 3 all squared is a plus. Okay, any questions? It's really important you ask me questions now because I'm about to go to the next slide and then it will be lost forever and ever and ever until I upload it onto Google Classroom. Ben.
I don't know how you did that really. Because how do you get the 2 times 2 times 3 part?
Okay. I'll do a little bit more color coding and I'll do a bit of a zoomy zoom so you can see what I'm talking about. Okay, so I'm just going to ask, are you okay with the fact that I got 2x all squared there? And are you okay with the fact that I've got 3 squared there? Okay, so if you look at the left-hand side of the board, again, not so good for the video, can you see that the middle term of a perfect square expansion is 2 times the first term times the second term?
Yeah.
So what I've got here is I've got 2 times, because that's what the perfect square rule says, the first term times the second term. Okay, so I've just written it in and then I calculated it and it gave me 12x just like it says there in the problem. And so because that's why I put check there, because my calculation fits what actually was there, I can then say, okay, it is definitely a perfect square. So it's definitely a check step. Is that okay, Ben?
Yeah.
Thank you for asking. That's really good. Anyone else got questions? It's the only way to get clarity is to ask. Yeah. 4 times 3. Where are you getting the 4 times 3 from? Yeah, I might actually come and there might be a little bit of a disconnect with the logic there, Tom. So if you're happy for me just to come and talk to you about that, that'd be good, I think. Yeah. Anyone else? Questions are awesome. Thank you. Every question is awesome. Genuinely. No, nearly every question. Not like, is it time to go yet? That's not an awesome question. Okay, here we go. Grouping is the one thing I thought you probably haven't practiced a lot or maybe not at all. Raise your hand if you have come across grouping before. I saw a couple of people going, oh, no. Okay, grouping has limited, in my opinion, grouping has limited application. There are some times when the only way you can factorize is by grouping, but almost always the stuff that you can do can be factorized by using any other method. So in a way, I feel like maybe I should have put grouping last rather than second last. But nevertheless, I'll show you how to go about it. What grouping does is it asks you to, if you can't factorize an entire expression, it says maybe you can factorize part of it and see what happens. Okay, so in the case of the expression on the board, I don't really need to reorder them, but potentially I might have to reorder these expressions to see what I can do with them. But what I'm going to do now is I'm going to underline the first two terms, and then I'm going to underline the last two terms, like so. So you see I've got a red and a green. Sorry for colorblind people. I apologize for using red and green. I just realized that. But the left-hand side is red, and the right-hand side is blue better. Is 3y squared plus 12. Now, what I'm going to use is just the reverse distributive law, just to factorize those two little components. And I want you to see what happens when I do that. On the left-hand side, I've got a common factor of x. Is that okay? I've got x squared y plus, so xy squared plus 4x. So I've got a common factor of x and nothing else. There's nothing else common other than a common factor of 1, which is boring. That leaves me with y squared, because x times y squared equals xy squared, plus 4, because x times 4 is 4x. Now, with the second two terms, I've got a common factor of 3. 3 times y squared is 3y squared, and 3 times 4 is 12. Are we okay with that? Have you noticed that the bit highlighted under orange is exactly the same? So I'm about to do something which is going to freak some people out, but I'm going to go back, maybe not you, Sammy, I think you'll be okay. But then I'm going to go back and just sort of unpack it a bit. So if you get this next step, awesome. If you don't stress. I'll try and unpack it a bit more for you. And then if you still don't get it, I don't mind too much, because like I said, I think grouping's a bit overrated. I don't really use it that much. Y squared plus 4 is just a number. You know, like, you know how 20 is a number? Well, 20 is just 16 plus 4. 16 plus 4 is a number. Okay, so if I gave Elizabeth 16 plus 4 chocolates for her birthday, and then I gave Paris 20 chocolates because, you know, she looked jealous, then they would have both the same amount of chocolates. And then if I gave Aya 4 squared plus 4 chocolates, she would also have the same as the other two. But they're all just numbers. So if you think about it from that perspective, y squared plus 4 is just a number, and it's a common factor for both of these expressions. And so I can take that common factor out, and what I'd be left with is the bit that's not orange on the line above, x in the first term and plus 3 in the second term. Isn't that neat? I think it's neat. But for some people, it's like, okay, my mind is blown, because you had brackets and then you didn't, and then you do again and say, what now? Okay. So what I'm going to do, if you get that already, that's cool. Just give me 30 seconds to explain a bit more depth, and then you can tune in again. So what I'm going to do on the left-hand side here in blue is just unpack that for a bit. So kind of what I'm doing is I'm getting a variable like a, and I'm saying let a equal y squared plus 4. We can do that. So we're just wrapping up y squared plus 4 into a single variable called a, which means that this line here would be x times a plus 3 times a. Okay? Now, I think when it's written like that, you can see that there is definitely just a simple common factor there of a. And what we'll be left with is a times x gives me xa, and a times 3 gives me 3a. That's just the reverse distributive law, no problems. But if we then look at back here, we actually said that a was y squared plus 4. So instead of a, we should really write what it really is, which is y squared plus 4, which is where, oops, we get our expansion. Okay? So I'm hoping that's clear to you. If that is as clear as mud, and you are really keen to work out what grouping is, then just let me sit down with you and we'll go through some problems until you get it. If you are really sort of like a bit like, no, I'm not going to get that, then it might mean there's 1 or 2 questions you can't answer in a test or whatever else. But generally speaking, in reality, grouping is not used that much anyway. So I'm not going to lose any sleep over it if you don't want to. Okay, is that okay with everyone for me to move on? You are, of course, welcome to ask questions. Okay, reverse box method. Now you can use reverse chicken beaking and lots of different things. I want to show you, sorry, I'll just keep that zoomed out. I want to show you the box method again because it's kind of critical for doing much more complex stuff. So even if you can solve that, you can factorize that expression without the box method, worth writing it down anyway. Okay, worth writing down. So the reverse box method basically says this. Now, if you have a look here, the box method was put the, if I've multiplied 2 binomials together, I basically put the parts of the binomial along the edges of my box, and then I fill in the box. So what we're going to do is we're going to start with the box and fill in the edges. Reverse box, right? Start with the box, fill in the edges. So here's my box. Accidentally in blue. And I can fill in some stuff. Like, for example, I know the top left-hand corner is just x squared. And like the bottom corner is 5 and plus 5 to be precise, just making sure I've got the operation in there as well. Is that okay so far? And the middle 2 boxes, the diagonal boxes, I know they have to add up to minus 6x. Nope. What do you mean? Down the bottom, don't think so. Let me follow through with what I'm doing, because it may be just that I'm explaining in a way that you've done differently. So let me just go through and then you can sort of ask me whether blah, blah, blah. Okay, so we've got the minus 6x there. Now with time and practice, you will be able to do this next step with more efficiency, like go to the right answer straight away. But I'm deliberately going to go through do the wrong thing to start with, just to model what you do. So what I do then is I say, well, for the top left-hand corner box, the x squared box, that really can only be formed by multiplying x by x. So there I have x times x equals x squared. Is that okay? Now, what about that bottom box? That bottom box 5 here can really only be found in a couple of different ways. And what I do is I look for combinations of numbers that will multiply together to give me 5 here, and I write them down. So again, I'm going to deliberately choose the wrong pair. I know that 5 times 1 will give me 5. So from that perspective, it works. But when I multiply the other 2 the clear boxes out, I get x times 1 equals x, and I get x times 5 equals 5x. Is that okay what I'm doing there? Just cross multiplying. X times 5 is 5x, x times 1 is x. When I add x and 5x together, I get 6x, not negative 6x. So that's not good enough. So I then do some sort of crossy-outy thing, and I try another pair of numbers that will multiply together to give me 5. Now, 5 being prime means we don't have too many options. We've got minus 5 and minus 1 as being the alternative. Now, negative 5 times negative 1 is positive 5. So we know we've definitely chosen correctly. And now if I do my cross multiplication, x times minus 5 is minus 5x. And then I've got x times minus 1 is equal to negative x. And sure enough, if I go crossways now, minus x minus 5x is equal to minus 6x. Is that okay? Cool. So what I can then do is I can then read across this or down this way and across this way and write it as a product, as a multiplication, and that's our factorization done. X minus 5 times x minus 1, or the other way around, doesn't matter. So that's the reverse box method. Now, what I found in my other class is that despite when I showed people this, some people said, yeah, but I kind of just went like this, Richard. I kind of went, well, let me see, what two numbers will multiply together to give me 5 that will add together to give me -6? And -5 times -1 is -6. And when you multiply, yeah, I do get -6. So they're the numbers. So they basically did it intuitively. And that's absolutely fine to do it that way, to sort of split this into its product and then add them to see. So -5 times a -1 is 5, and -5 plus -1 is -6. And so these numbers are right, and I can just factorize it. There's nothing wrong with that. And if what I just said went over your head, there's nothing wrong with you not knowing that either. But just for those who see that and say, well, that's how I've normally factorized in the past, I want to warn you that doing something like this, and I don't know if this works out or not, so I'm just making stuff up. No, bad choice. Something like that. You can't say what two numbers will multiply together to give me 9 that will add together to give me -12 because of the 2 instead of the x squared. So that sort of intuitive sort of like what numbers will work only works when the coefficient of x squared is 1. Okay, if the coefficient's bigger than that, then you need to be much more careful, and then using something like the reverse box method is good. I have an alternative method called the cross method. You might have a third alternative. Can I just suggest before you use your method, if it's not one that I've approved, just check with me first. It's not that I'll say you must do it my way or not, but I might see your method and go, yeah, it works for these, but it won't work for these. You better use a different method. Or I might even say, you were lucky it worked that time because it won't work any other time. So it's just worth checking in with me. So I'm not trying to be, really rigid and you have to do it my way or no way. It's just worth checking. Alrighty, any questions? Last thing before I get you on to work. I still went too long. I talked too long, I'm sorry. X cubed plus 8x squared plus 16x. This is a combination problem in that you're going to use multiple techniques. I'll do it really quickly. You can always review the video if you need me to go through slowly. So what I do is I go through my steps. The first thing I should check for is common factors. X cubed, 8x squared, 16x. The only common factor of the coefficients is 1, so that's a bit useless because there's no coefficient of x cubed. But I see that x appears in every single one of my terms, and therefore x is a common factor. And specifically, the highest common factor is x, not x squared or x cubed. Okay, x is the highest common factor. So then I put my brackets out and I see what I've got left. I've got x squared because x times x squared is x cubed, plus 8x because x times 8x is 8x squared, and then I've got 16. Then I get a bit suspicious because remember the next stage is does it fit a pattern? And my suspicions are that it fits a perfect square pattern because I've got a square here and I know that 16 is 4 squared. So in my head, but you could do it literally on paper, I can say, okay, that's x squared and that's 4 squared. And then I'm just going to check, do we have in the middle 2 times x times 4? Well, 2 4s are 8. So that should be 8x. Do I have 8x? Yes, indeedy doody dandy, I do. So that means I'm good to go. It means that my fully factorized expression is x times x plus 4 all squared. And I'm done. So you can see there were multiple factorizations there. Okay, that's it. Any questions about that last one? So you've got to sort of collect your factors as you go along. Okay, I'm just going to stop there for a second. Yeah. What's that got to do with anything, Thomas?